Welcome back to Grade 7 Geography, Unit Number 1, Physical Patterns in a Changing World. This is Lesson Number 6, What Factors Affect Climate, and What Causes Climate Change? Climate factors are the conditions that affect the climate of a particular area. There are 6 major natural climate factors. Some of these affect all parts of the Earth, while some affect only small parts of the planet. First, winds help move energy around the planet. The world's wind systems are complex due to the fact that the Earth spins on its axis from west to east, and because land and water are not distributed evenly over Earth. The wind that blows most commonly in an area is the prevailing wind. Trade winds are winds that blow steadily toward the equator from the northwest in the northern hemisphere or the southeast in the southern hemisphere. An air mass is a large volume of air with similar conditions of temperature and moisture throughout. Air masses that form over warm water bodies carry warm, wet weather. And here in this image, you can see different major air masses in North America. So you might well put the video on pause just to take a closer look at these. I'm not going to expect you to memorize the names of all of these air masses. 2. Latitude refers to how far north or south a place is from the equator. The sun's rays are most intense near the equator. You can think of that as uh, like a line cutting the Earth in half across, making countries near the equator warm or hot. Other areas like Canada and Northern Europe, which are farther away from the equator, receive less intensity from the sun, so they have cool or cold climates. Okay, sort of makes sense. As you're getting closer to the Arctic Circle, or if you're getting closer to the Antarctic Circle, it's going to get colder. 3. Oceans make up 70% of the Earth's surface. Within the oceans are massive flows of water called ocean currents. Ocean currents help bring warm and cool water to different regions. Warm ocean currents begin in the tropics and bring warm air north, while cold ocean currents start in the polar regions and bring cold air south. And now I am not going to make you memorize how many ocean currents there are or where each one takes place, but I just want to point out on this image here that there are several ocean currents. Okay, and so the ones that are marked in red, they're the ones that are bringing warm air north. Ones that are marked in blue are bringing cold air south. And I have a feeling that Hillary may talk more about this in science. 4. Elevation affects local climate. Areas that have a higher elevation have cooler temperatures. Areas that have a lower elevation have warmer temperatures. Just think of it as like going up a mountain. As you're going up a mountain or even some hills, you'll find that it starts feeling cooler. 5. Geographers use the term relief to describe the difference in height between the highest point and the lowest point in an area. Mountainous areas have high relief, while plains have low relief. Mountains cause moist air to rise. As air rises, it cools. Wind carries air moisture, and eventually the moisture returns to the windward side of the mountain as rain. This is known as relief precipitation. Okay, and just showing you here with an island or a mountain range. Okay, so you've got winds that are building up. It's causing air to cool down and condense, form clouds, so you get precipitation. Um, but then as the wind's moving along, as you come down the other side of the island or the mountain range, you're going to find that the air is actually warming. 6. Bodies of water, such as lakes and oceans, heavily influence climate patterns. Since they take so long to heat up or cool down, they help keep the temperatures of surrounding lands stable. Places near large bodies of water usually have lower temperatures, warm summers, and cool winters. Places that are separated from bodies of water have higher temperatures, hotter summers, and colder winters. Earth's climate is a balance between how much energy is received from the sun and how much energy leaves Earth. Sometimes the Earth receives more energy than usual from the sun due to natural events. The sun has periods where it gives off more energy, about every 11 years. Changes in the tilt of the Earth's axis, as well as volcanic eruptions, are also natural events. So they're things that we don't cause, they just happen. Greenhouse gases are gases in the atmosphere that contribute to the greenhouse effect by absorbing energy from the sun. When produced naturally, greenhouse gases help keep Earth warm and protect life on Earth. Sometimes too many greenhouse gases get caught in the atmosphere through natural means, and this causes climate change. And we're going to talk a lot more about this in future lessons, and I have a feeling Hillary's going to talk about this in science as well. But uh, here's a quick summary of the greenhouse effect. So we're releasing carbon dioxide and other gases, and they get stuck in the atmosphere, and it creates this almost like a force field where heat is being trapped in the atmosphere. It keeps the Earth warm. And then, of course, the sun is still shining on us, and some of the sunlight that hits the Earth bounces off, and this becomes heat. So this is what's uh, it's a greenhouse effect. We call it that because it's like when you go into a greenhouse uh, where you're growing plants, it's very hot inside because the greenhouse windows keep the heat in. And of course, they also absorb sunlight. Unfortunately, human activity has caused a great deal of unnatural climate change. Humans are producing far too many greenhouse gases by polluting and using too many fossil fuels. By that I mean oil, natural gas, and coal. Major human activities such as electricity production and industrial production are responsible for unnatural and harmful climate changes. So all of these activities here, uh, oil tankers, factories, drills, uh, burning coal, all of those are adding to the greenhouse effect. Dealing with global climate change has become a major issue in our lifetime. Not everyone agrees that action should be taken to deal with climate change. Some scientists and governments believe that there's nothing we can do. Some believe that climate change is not even real. Now, on the left here, we see David Suzuki, who is a well known and well respected Canadian scientist who is urging Canadians to reduce the amount of pollution they create. On the right, however, Patrick J. Michaels is an American scientist who disagrees with Suzuki's concerns about climate change. So, here's a question for you at home. Who do you agree with and why? This is something we should discuss in tomorrow's class. Those who feel that humans can and should fight climate change have suggested two methods of dealing with climate change. Mitigation is a set of actions that can be taken to reduce the consequences of a problem. Examples of mitigation include switching from fossil fuels to solar and wind power. The other strategy is adaptation. This means that humans can grow crops that will survive in the new climate and build more parks and green spaces inside of cities. And here's just one example. Greenacre Park in New York City is an example of a pocket park. This is a human-made park that's within a major city. You may even see one or two in downtown Toronto. They look beautiful, and they're also helping to promote the environment because of all the natural vegetation. Okay, so I'm going to leave you with a couple of questions to work on at home, and then we'll discuss them in tomorrow's class. Here's the first question. Is climate change an issue that we should be concerned with? And two, what things can we do at home or at school to reduce pollution and to help protect the environment? So you're going to put the video on pause so that you can write down your responses to these two questions. We will discuss them in class tomorrow. If you're not ready to answer these two questions, it means you need to go back and you need to watch this video at least a couple of more times. And then when you get back to this slide, put the video on pause. And until tomorrow's class, this concludes today's video.